Hello, I'm Wonkyo from Autonoma University. In this video, I'd like to introduce a summary of the paper, a study of memory placement on hardware-assisted tiered memory system. To begin with, assume that a process is running on the CPU 0. In the recent version of the Linux kernel, the memory of the thread is allocated in the local memory. Based on the NUMA distance, if there is no space for memory allocation, the kernel automatically allocates memory in the next remote memory. However, on the non-volatile memory, there are few limitations when the traditional policy is applied. First of all, the traditional memory placement shows a negative effect when Optane-DC persistent memories is used. This is because the latency on the local means is slower than the remote cache. Second, a DRAM cache cannot use the data in other remote main memories. The reason is that the current memory controller does not allow to do that. The last observation is a limitation on Autonoma. When threads try to access the data in the remote memory, the accessed data will be migrated to the local area. The problem is that since the cache structure is a direct map, one cache block must be evicted in order to put the migrated one. These steps are time-consuming and cost a lot. To resolve the previously mentioned limitations, we firstly propose the DRAM-first policy. What the policy does is, when there is not enough spaces on the local caching area, the kernel does not occupy the main memory first. Instead, the kernel directly uses the empty remote cache area, so the system fully utilizes both DRAM caches. The second proposed thing is the cache-aware on-and-off Autonoma. Again, when the situation on the image happens, threads will access the remote data. In this moment, we simply turn off the Autonoma property. As a result, there is no extra procedure that we have to do. The final slide is the evaluation result. In the left graph, our DRAM first shows better performance on the micro benchmark, and in the right figure, the proposed model shows 21% improvement in the map cache D. Thanks for watching video. If you have any questions, please send an email to me or other authors.